Hi everyone, we're going to continue talking about how to prove triangles are similar. In yesterday's lesson we learned about AA or angle-angle. Today we're going to learn two more theorems that look very familiar, SSS and SAS. We learned those theorems about congruent triangles. Today we're going to apply them to similar triangles. As you know, SSS stands for side, 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 same as it did when we talked about congruent triangles. And what we learned earlier this module is that side lengths of similar triangles are proportional. So they're not congruent, they're proportional. So when we say SSS for similarity, it still means side, 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 but it doesn't mean three sides are congruent to three sides. It means three sides are proportional to three sides. So what it means is you want to test each pair of sides. And remember, proportional means if you divide, you get the same number each time. So if I take each of the three sides of one triangle and divide by each of their three corresponding sides, if I get the exact same number every single time, the triangles are similar by SSS. So let's try it out. Here's an example. So what we have two triangles. We're trying to decide if they're similar by SSS. And one thing you notice is they're kind of turned. You know, a lot of times when I give you similar triangles, they're right next to each other and it's really easy to see what matches up. But this time I kind of twisted them around. Maybe I reflected it. We're not really sure. So in a question like this, what you want to do is go by size. You say, all right, in my first triangle, or in the left triangle, the smallest side is an 8. And over here, the smallest side is a 6. Now the biggest side in the first triangle is a 16, and the biggest side over here is a 12. And then that just leaves the middles. The middle side here is 12, the middle side here is 9. So now all of a sudden we have them matched up. So what we want to do is we want to do 8 divided by 6. We want to do 12 divided by 9. And we want to do 16 divided by 12. So I did red first, always left to right. So I did 8 divided by 6, the reds. I did 12 divided by 9, the greens. And I did 16 divided by 12, the blues. Now you can either grab a calculator and divide and get a decimal, or you can reduce them as fractions and you should get the same thing each time. I think we get 4/3 for each of these. So with 8 over 6, if I divide each of those numbers by 2, I get 4 over 3. Now the 12 and the 9, I can divide each of those by 3 and I get 4 over 3. And the 16 and the 2, I divide each of those by 4 and I get 4 over 3. So the answer is yes, the triangles are similar by SSS because each side, when I divided them or when I made fractions, gave me the exact same number. It has to be all three. If I get 4/3, 4/3, and 5/3, not similar. Okay, our second theorem today, again, a familiar looking one, SAS stands for side angle side. Now remember, side angle side, just like with congruence, it has to be in order. It has to be two sides and the angle in between them. The difference is with congruent triangles, we wanted everything to be congruent or equal. We wanted two sides equal, we want one angle equal, triangles are congruent. Well, SAS still means side angle side, but instead of and the angle still means congruent, but for the sides you're always saying proportional. So basically right here, these two triangles would be congruent by SA, or would be similar by SAS, because number one, the angle is congruent. That's marked in the picture. Now the sides, I have a 12 and a 36. 36 divided by 12 is 3. And for my other side, I have a 15 and a 45. 45 divided by 15 is also 3. So I have two sides that are proportional. I don't need to know the third one. See, remember, we don't know what this side is over here and this side over here. If I did, I could do SSS. But this is different. This is for when you only have two sides and the angle in between them. So this would be enough to say the two triangles are congruent. So we have three ways so far. We have AA, two angles, you don't need to worry about sides. We have SSS, all three sides, proportional. And then this is our special case where you have two sides proportional. You don't know the third side, but you know that the angle in between them is congruent. That's also enough to say the triangles are similar. And even though I just said this, let me click through it for the notes here. We have 3 ways to prove triangles are similar. Number 1, if 2 angles are, I said equal, I should have said congruent. If 2 triangles are congruent, the triangles are similar, no matter what. You don't need to know anything else. Number 2, you could show all 3 sides are proportional. Or number 3 is what we just talked about, SAS. You show 2 sides are proportional. Maybe you don't know that third side, but you do know the angle between the 2 sides is congruent. So just remember the difference between when we did this for congruence in book 1 and for when we're doing it in similarity right now is that the S's always mean proportional. S doesn't have to be congruent. Sides don't have to be congruent. They're proportional. So let's go through a few examples, kind of like the one we did yesterday. We're going to say, number 1, for all 3 examples, really, it's going to be the same directions. It's going to say, are these 2 triangles similar? If so, give a reason. So I look at this question. This is actually very, very close to the one we did yesterday. I have one congruent angle. Angle F and angle K is marked congruent, so there's one A. Then I look at the picture, I go, well, I got that bow tie picture. And we know that when you have the 2 triangles that kind of look like a bow tie like that, you get vertical angles. So this one is congruent to this one. That's all I need. I don't need to know the third angle. I don't need to know anything about the sides. I can automatically say yes by AA. So yes, these 2 triangles are congruent. My reason is AA. I'm done. That's actually pretty much the same question we did yesterday. All right, let's try another one. Let's see if these triangles are similar. So I look at it and I go, okay, well, there's a lot of angles marked here. Angle E, angle K, angle J. But if you look very closely, there's no congruent angles marked. You have 1 arc on E, 2 on K, 3 on J. It's kind of like a trick question. It marks some angles, but what it's actually showing you is that they are not congruent. It's saying E, K, and J are all different angles. We don't know anything about F. So one thing I could do is, we do have the vertical angles again. It would be 4. 1, 2, 3, 4. 1, 2, 3, 4. So I could mark those angles congruent, but it's still not enough. It's only 1A. I don't have any information about sides, so I can't do proportions. I don't have a second angle. This is a no. We do not have enough information to say that these triangles are similar. Now, be very careful with that. I remember I said it's kind of a trick question. You see all the angles marked and you think, okay, well, it's probably AA. It's not AA. It's actually no. We don't know if these triangles are similar or not. Now for our last question, what we have is some sides and some angles. So immediately I'm thinking maybe an SAS on this one. Let's find out. So I have 2 angles marked 60. That means they're congruent. If the angles are equal, equal means congruent. So now if I want to do SAS, I have to use the 2 sides that make the angle. So the angle is between them. So I don't want to use the 12. And that's good because that matches up with this K anyways. So what I want to do is the two numbers that are kind of around the angle, the 8 and the 20 and the 4 and the 10. So let's do it just like we did with SAS. Let's match up by size. Of the 2 sides, the smaller one here is the 8 and the smaller one here is the 4. And of the 2 sides, the bigger one here is the 20 and the bigger one here is the 10. So let's divide and see what we get. With the blues, I get 8 divided by 4, which is 2. I don't even need fractions, that's an easy one. With the greens, I get 20 divided by 10, which also equals 2. Now I don't know the third side, but I don't need to for SAS. So what I have is the 2 sides are proportional because when I divided them I got 2 both times. The angle in between those 2 sides is congruent, or equal, 60. So this is a yes by SAS. And I think that's what we're going to focus on for the homework, is you guys taking a look at triangles and deciding if they are similar. Your answer could be no, they're not, yes by AA, yes by SSS, or yes by SAS. I mean, basically 4 possible answers. You got to make sure you know how to find the right one.